Hey everyone, this is going to be a tutorial on how to solve Wireshark 2222 on picoCTF, however you say it. This is a great resource if you're looking to get into cybersecurity or get better at capture the flag events. This is a great resource, and we're just going to be covering this forensics one. This was used in picoCTF 2021 challenge. Not a lot of people like this one, and I think you'll see why. But we're given a PCAP file, so we can open this up in Wireshark. You know, your OS of choice. So let's take a look at the PCAP file here. And okay, so we're given, right off the bat, we can see that this is going to be encrypted. We've got TLS v1.3 as a protocol here, and if we go through, there's some HTTP requests. And it seems to be a, we're trying to get a page, but HTTP requests here. There is, it just seems to be Kerberos encrypted. So if we scroll down here a little bit, we'll actually get to, it's just a really long session here of getting pages, and all the stuff is encrypted because we don't have the key to be able to decrypt this TLS traffic. So if we keep scrolling, eventually we're going to come across get flag. So this looks interesting to us, right? So if we go down to, if we follow this HTTP stream, we actually have a flag right here, but this isn't the answer because there's a bunch of these requests. If we actually filter, if we apply a filter here of HTTP and we do Control F on the, let's see, let's do 200 OK. If you take a look down here, each one of these is, I mean, there's a bunch of flags that are being returned. So this is a red herring. You can try each one of these if you want, but it's not the answer. But what we want to take a look at here is that all of these requests are going to this IP address, 18.217.1.57. That's pretty interesting. If we go to statistics and we go to, where is it, the communication conversations and IPv4, we can see that there is traffic here going to this one. So let's actually apply it as a filter, and then let's see what we get. Yeah, so we get all of this information here, but still it doesn't give us, it's not going to give us the correct flag. So what do? What we notice is that there's a lot of these DNS requests that are going to seemingly a random string, a random subdomain, and then redstripherring.com. If we scroll up, here's another one. Here's another one. Here's another one. So let's actually get this down to only the DNS. So let's do DNS. Okay, so now we've got the conversation between the source and this IP address, but only the DNS queries. Okay, so you can see that they're all different. Now if you go down, the last one here, because these are sequential. There's a double equals sign at the end here. Now if we're thinking sequentially, this is an indication of probably base 64. So let's actually combine all of these different, all of these strings. So first let's copy this, and I'm going to open up Notepad, paste that one in, and the next one is this one. So let's copy it, paste it, and then this one. And the next one is down here. So let's copy that. And then after Z is the Y. Whoops. And after this one, we copy FQ. Okay, and now we've got, now let's get rid of all this extra stuff that we don't need. So we can go ahead and just kind of delete this. I'm sure regular expression would work better for this. And we delete this, and we delete this, and we delete this. And then now let's actually go through and replace. We're going to replace every instance of the dot regtrim pairing because we don't need it. Replace it with nothing. Replace all. Okay, and now we've got that. Now we're left with the string, so let's reformat. Alright, so now we've got a base 64 string. Let's actually copy this, and let's open up CyberCTF, and we're going to do from base 64. We're going to paste this in, and we've got our flag right here. And that's how you solve that. So that's a little bit of forensics, and hopefully this helps you.